All right, now we're continuing with that problem from the other lesson. So what do we have so far? We got 13.2 degrees. We have this length right here, and we're trying to find this one. So we just use our basic trig functions now. Okay, it's just a regular right triangle, and you've got a angle here. You've got an opposite side, and you're looking for the adjacent side. So which trig function is opposite and adjacent? It's the tangent. Thank you. So it's the tangent of 13.2 is equal to the opposite, which is 75, over the adjacent, which is x. Now this algebra is a little bit more involved than the other one was. After you get used to it, it's really not that big of a deal. Do you remember how to do this? How do you think of it? Just switch them, right? I like thinking of it like that. Just take this x, put it up here, put the tangent of 13.2 down here. There is an algebraic reason for it. We've talked about it in the past. But it's just x equals 75 divided by the tangent of 13.2 degrees. Who's ready with an answer? 319.8? 319.8. And it's in what? Meters, right? And that is this distance right here, 319 meters, from the bottom of the ship to where the wreck is. It says find the angle of elevation of the sun if a building 125 feet tall. Which one of these lines is the building? The vertical one, right? Okay, so it's 125. That's 125 feet. Cast a shadow. Which one of these is the shadow? This one on the bottom, right? A shadow. You know, you don't see the shadow in the middle of air, do you? You see it on the ground like this. So the shadow is 196 feet. And it says find the angle of elevation of the sun. Now, what does that mean? Well, here's the ground. The sun's rays. This is the direction of the sun, isn't it? Along this direction, hits the top of the building and keeps going down to the ground. Would you agree? So we're trying to find this angle right here. What do you want to call it? Call it theta. Now this is a right angle because it's a ground in a building. Again, we're assuming the building is not the Tower of Pisa, right? This is a vertical building with the ground. So we got to solve for this. What sides do I have? Opposite and adjacent. Use the tangent again, but now we're doing something a little bit different. We're solving for the angle. We talked about this earlier, right? Second function. So it's opposite over adjacent, so it's 125 over 196. Now in order to find theta, we take the inverse tangent. That's second function on your calculator. So you hit 125 over 196, and then you hit second function tangent, or if you have a graphing calculator, you hit second function tangent first, then you put 125 divided by 196, and Wendell, what do you get? 3 what? Just 33? Okay, so 33, and it says round to the nearest degree, right? So it's just 33 degrees. Nearest degree, no decimals, right? Just 33 degrees. And that's what that angle is there. Easy, right? Yep. Just got to know how to draw the pictures from the words. You just got to be able to draw the pictures from the words. But I'm trying to explain to you in a very quick way, you know, what all these things represent, and it shouldn't be that hard. 16 is a little bit tougher, so let's take a look at that. Here we go. All right, let's take a look at this problem right here. This is what was given on the test, this picture right here, and I just kind of redrew it so I could write on it, you know, see the weird looking palm tree and the sun and all that kind of stuff. So it says the sun's angle of elevation is 76 degrees, so that's what we talked about before in that last problem with that angle. So we'll just write that in there, 76 degrees. A tree tilted at an angle, this line right here represents the tree, forms a 4 degrees from the vertical. Here's the vertical right here, here's the tree, 4 degrees. Now they showed you all that stuff on here anyway. Cast an 18-foot shadow. Again, the shadow goes along the ground, so that's 18 feet. Find the length of the tree to the nearest tenth of a foot. So what we want to do is find this distance. Let's just call it AB. Is that all right? All right, so we're going to try to find that distance AB. Well, what do you think? Where would we go from here?
Wrong.
Okay, here we go. So what we're going to do, since we know this angle right here is 4 degrees, we can find this angle right here, which is 90 minus 4, which is 86 degrees. We could also find this angle right here. So it's 180 minus 76 minus 86. And what is that? Is that 18? Okay, so this little angle up here is 18 degrees. Now watch what we have. What are you trying to do? You're trying to solve for AB, or we'll just call it x. Is that all right? So we're trying to find this length right here. Well, you know the angle opposite this side, and you know these two, this angle and this side opposite to each other. So that's a perfect situation where you can use law of sines. So let's use law of sines on here. We're trying to solve for x, so we're going to go x over the sine of 76 equals the side. Now it just happens to be that both of these are 18. I don't know why, but anyway it is. So it's 18 over what? The sine of this angle, which is the sine of 18. Right? Multiply by the sine of 76. And then just throw that in your calculator. And I believe you get 56.5. Is that what you got? It's in feet. Yeah, it's in feet, so we just write 56.5 feet. And there you go. So the only reason you needed this 4 is to find this to be 86, didn't you? Okay, once you found this, you knew that this one was. Then it's just basically using the law of sines to find the rest of it.